Hello everyone, welcome to my audio lecture. With continuation with my previous video on set, this is my next video on types of set and operations on set. Okay, so in the previous video we have already discussed about two types of set, that is the empty set and finite set. Okay, empty set is a set having no elements or whose cardinality is 0. Cardinality means number of elements in a set. Okay, and finite set means a set having finite number of elements, like we have discussed about the set of vowels in which the elements are a, e, I, o and u. So the number of elements are countable, that is 5. So this set is known as finite set. Okay, so next move to the different types of sets. Next is the infinite set. Okay, infinite set means a set having infinite number of elements, like set of natural number. Set of natural number consists of elements like starting from 1 to plus of infinity. So the number of elements in this set we cannot count, that is the number of elements are uncountable. So this is known as infinite set. One more example is set of integers, which consist of elements from minus of infinity to plus of infinity including 0. Here also we cannot count the number of elements, so this set is also known as infinite set. Okay, next is equal set. Equal set means two sets are said to be equal if they share the same element and equal cardinality. Cardinality we have discussed in our previous video, that is the number of elements. To compare two sets, we have to see the cardinality. Suppose one set is there, here the elements are 1, 2 and 3, and another set is B where the elements are 1, 2 and A. Now the cardinality of both the sets are equal, that is 3, because 3 number of elements are there, but still A is not equal to B because the elements of A is not equal to B, because 3 is the element of A which is not present in B, so A is not equal to B. If instead of A, if there is 3, then we can say A is equal to B, because the cardinality is also equal. To check two sets are equal or not, two conditions are there. First one is the cardinality and the second one is the number of the elements should be same. Okay, so next is subsets. Okay, there are two things. One is the subset and another is the proper subset. Okay, most of the students get confused in these two terms, so let's differentiate between these two. Subset is denoted in the form of this symbol and proper subset is denoted in the form of this symbol, and only one difference is there. If I have said A is a subset of B, that means all the elements of A should be present in B, and all the elements of B can be equal to all the elements of B. That means equality condition is present in subset, but in case of proper subset, at least one element should be there. If we say A is a proper subset of B, that means at least one element should be there in set B which is not present in A. Okay, let's see with an example. Suppose A is a set in which elements are 1, 2, 3 and 4. Okay, and B is a set in which element is 1, 2 and 3. So in this case we can write B is a subset of A, or we can easily say that B is a proper subset of A, because there is one element 4 which is not present in B. Okay, but if there is a set C in which the elements are 1, 2, 3 and 4. In that case, we can write C is a subset of A, but we cannot write C is a proper subset of A. Okay, so we can simply change this name because there is a ambiguity because of this symbol. So let's change the name of this set. Suppose this is set D, and here also we have to change the set. Okay, so I hope you have differentiated between both subset and proper subset. Only one difference is there. In the case of subset, both the set can be equal, but in case of proper subset, at least one element will be there in set A which is not present in B. That is why we have written this equality sign under below this subset sign. Okay, and next is the proper subset. Proper subset, which I have already discussed. Let's see the definition. If A is a subset of B and not equal to B, then B becomes a proper subset of A. That's what I have explained in the previous slide. Suppose A is A, B and C. That means if B is a proper subset of A, then at least one element will be there in B which does not present in A. Okay, so next is proper subset. A set A is subset of B and not equal to B, then A becomes the proper subset of B, which we have discussed in the previous slide. Once again, I will explain that if there is a set in which 3 elements are there, then the set B, which is a proper subset of A, at least one element should be there in set A which is not present in B. That means always the set B will be smaller in size, or the cardinality of set B will always be less than set A if B is proper subset of A. Okay, and superset is if B contains all the elements of A, then B is called the superset. Here we are comparing with the larger set is A. So A is the superset. Okay, or we can say the universal set from where all the elements belong, that is known as a superset. Okay, and next is proper subset. Next one is power set. Okay, so power set is what? The power set of any set A is a set of all possible subsets of A, and it is denoted by power of A. If there is a set A where the elements are A, B and C, so power set of A is the set of all the possible subsets. The first subset of any set is the phi, which I have already discussed in my previous video, that is empty set. Okay, that is also known as null. Okay, phi, it is also known as phi. Okay, next is set A, in which A is a set in which only one element is there. Again, B is there, C is there, and we can now pair each and every elements like this: A, B and A, C, and the last one will be the A, B and C. One formula is also there to find out how many number of elements should be there in a power set. If the cardinality of set A is 3, then the cardinality of power set is 2 to the power 3. And what is 2 to the power 3 is 8. So now we will count how many number of elements are there in power set. That is 1, 2, 3, 4, 5, 6, 7. One element is missing. That is, I think, BC. One more element is there, that is BC. Okay, Let's change the ink so that you will be able to view. We have to simply make sets of every elements. Remember that the order should be same. We cannot write it in CA, okay, because A is appearing first, so we have to maintain the order. Okay, so the number of elements in power set will be 2 to the power number of elements. Here the cardinality of set A is 3, so 2 to the power 3 will be the number of elements in power set. Next is the disjoint set. Disjoint set means a set having two sets. When two sets have no common elements, then they are called disjoint sets. Suppose there is a set whose elements are 1 2 3, and B is a set whose elements are A, B and C. Here both the elements are totally different, where no elements are there in the which are common in both the sets, so we can say that A and B are disjoint sets. Disjoint sets are simply, we can say that, two sets in which no element is common, so we can say disjoint set. I hope you understand all these points. So thank you so much. If you have any doubt, please comment your doubts in the comment section. Thank you so much.